Good evening, students. Good evening, all of you. We're still waiting for more students to join in. Please inform everybody to join in the session. If I'm audible, you can drop yes in the chat. Okay, thank you. Thank you. I hope you all have started to work on your projects, isn't it, students? How many of you have submitted your project already? You can let us know in the chat. Okay, completed, submitted already. Right. So how many of you have submitted your projects? You can drop it in the chat. So whatever you're filling in the feedback, okay, in the upload project section, you will be uploading your project. And also there are other questions that you can see over there. So while you're answering those questions, please ensure that you give descriptive answers. Do not just say yes or no, right? Make it more descriptive. And those who doesn't know about this project work, please go to your Telegram group, check the pinned messages. Already I have pasted the necessary details about the project submission process. You can refer to that message, or if you want, you can refer to the session recordings, right? Please do start working on your projects, and we are in our final week. As you all know, 12th of July is the deadline for course completion and pasting links, right? And 15th of July is the deadline for project submission. So please ensure that you're all stick to your timelines. Okay, still some students are asking, ma'am, I'm doing a project on healthcare diabetes. I'm doing a project on so-and-so topic. See, the choice of topic is yours, right? Like you can do it as an open project, but please ensure that you I hope you're all aware that it is your individual project, not a group project. Some of you are still confused with that as well. It is supposed to be your individual project. Okay. Second, the choice of topic is yours. You can do your project on any topic, but you need to use artificial intelligence in that, as that is the base of this program, right? And third thing, you have the project template with you all in the Telegram group. Use that template only. Those who are submitting your project without the template cannot be validated. So please ensure that you are using that project template and add in your inputs in that and convert that into PDF. And once the PDF is ready, use the upload project option, fill the necessary details and give your feedback, and then attach your PDF over there and submit it. Project work. If you have any doubts, just scroll up on your Telegram group. You will be able to see all these details in the messages itself. Check in your pinned messages. Yes, so some of you have raised, ma'am, some modules are duplicated. We can see the same kind of course in two different modules. It is already raised with the technical team and they are working on it. Soon it will get fixed. Okay. Even in YouTube Ninja Gaming, you have raised it. It is with the technical team. You will get it. Okay. It will soon be sorted. I mean. Okay, Jolly Patel, if you are an AICTE student, you will get your AICTE student ID in your AICTE portal. If you are a GTU student, in that place, you can mention that you are a GTU student. Simple. Is that clear to you? You can acknowledge the same. Just use the template, Dinesh. It has all the inputs in there. Just stick to the template. Do not use your own, designs and all that. Just use the provided template. Yes, you need to complete all the courses under the advanced section, not just AI fluency. I repeat, in every session, I am telling you this. You need to complete all the courses in your advanced section. Right? There are 7 courses in your advanced section. So please ensure that you are completing all those 7 courses. If you are a GTU student, in the place of your AICT ID, you can just mention you're a GTU student. Okay, no problem. Only the AICT students can add in your AICT ID. Otherwise, you can mention that you're a GTU student. If you want the exact update, I can give you by tomorrow. Okay. I'll ask for a solution for this as well. The deadline for the course completion and pasting link is 12th of July. Today is 8th and you still have 4 more days. And yes, we are in the final week of our internship. You would be having one more technical session and your last AMA session this week. That is it. And Kishore, you're asking 100% accurate results. Your technical trainers will be able to answer you this question in our today's session. I think we are good to start the session. If anybody is missing, if your friends are not here, please inform them to join in the session. Now I would like to hand over the session to the technical trainer. Over to you, sir. Thank you.
Thank you, ma'am. I hope I'm audible to everyone. Everyone please confirm in the chat box? Okay, just going to share my screen. Let me just open the chat box so that I can keep an eye on your doubts. Perfect. So we are good to go now. Guys, once more, is my screen visible? Am I audible loud and clear? Perfect. Perfect. Thank you. Thanks for your confirmations. All right. So in the last session, we have completed with NLP, right? And we have discussed multiple algorithms before in machine learning, supervised and unsupervised. So today, we are going to move forward. We are going to take one more step. That is going to be a type of advanced learning. The topic of the today is going to be deep learning. All right. Perfect. Moving ahead. So what we are going to learn today, we'll be discussing what exactly deep learning is, how does neural network work, what is the basic difference between deep learning and machine learning, the things that you have already done, forward and back propagation, what are the hyperparameters in the neural network, and multi-layer perceptron. So all these things we are going to discuss today, and we are going to do 2 projects today. One is going to be nothing but Hello World of Deep Learning, that is going to be handwritten digit recognition using ANN, that is artificial neural network, and we will be taking one more step in the field of deep learning, that is going to be CNN. We are going to discuss CNN as well, and we are going to do one of the very famous project, that is going to be cat and dog image classification. All right, so let's move ahead. What is deep learning? What exactly deep learning is? Now, whatever the problem that we have solved, we have used some machine learning approach, right? We have used some algorithms. Based on the algorithms, we have created the models. But the thing is that in machine learning, we are going to work only on structured data, right? Only on structured data. Structured data means what? The data that we can put into rows and columns. So you can see, like, we have created data frames, we have used CSV files, you can also use Excel file. You can also extract data from any relational database table like MySQL database table. But all the data is going to be structured. What about unstructured data? Okay, what about unstructured data? I'm having one question for you. Okay, just moving ahead, I'm just going to draw something and let me know what I am drawing. Okay, can anyone tell me what I have drawn? I have drawn 5 figures total. I have drawn 5 figures. What are these 5 figures? All figures are three. Okay, everyone is saying three, three, three. Okay, perfect. Okay, now one question. Now you can see this figure that I have drawn is different from the figure that I have drawn over here. Now, how can you say that this figure 1 and this figure 4 both are 3? You're saying all the numbers are 3, but on what basis you're saying all these numbers are 3? Okay, I'm getting similarities, numeric, okay, the value. Okay, not don't take the value. I'm talking about the images. I am having one image of 3 here. I'm having one image of 3 here. Okay, size and similarity. Now, I got an exact word from here, from Rishikesh, pattern, right? Both of these figures are following patterns, the same patterns. Now, understanding the pattern in the images is not going to be possible for machine learning algorithms that we have used. Here we have to go a little advanced. We have to use deep learning. So what exactly deep learning is going to do? Deep learning is going to mimic human brain. It is going to mimic human brain. What is our brain made up of? What is our brain made up of? Everyone? Neurons, exactly. Our brain is made up of neurons. Now here, for understanding the difference between the patterns, we have to mimic human brain. Now our brain runs behind pattern. We are able to recognize our friend because they are having different pattern on their face, right? It is the facial pattern, the features. They're having different features from us. So that's why we are able to recognize our friend. So sometimes we also get confused when we are going to have, two twins together. Who is Ram? Who is Ghanshyam? Right? So basically, both of them are having similar patterns. Now here, differentiating between the patterns is possible because of our brain. Like we have learned from childhood, we have trained our brain. Okay, if I'm going to have some rounds and rounds like here, if the picture is following this type of pattern, then it is going to be 3. So here we are going to mimic human brain. That means a brain is made up of neurons, right? Neurons. And we are going to create artificial neural, just a second, neural network, artificial neural network. All right, neural correction. I'm getting right answers here in the chat box. So basically, how we are achieving AI with the help of machine learning and deep learning, and we have already discussed machine learning is nothing but subset of AI, and deep learning is going to be the subset of machine learning. Now in industry, everyone is calling it machine learning because we have gone very forward now. The time that we are living in, you are not going to get any separate role for deep learning engineer. If you are going to find any role in the industry that is saying machine learning engineer, you should know machine learning and deep learning both. Right now, deep learning, like machine learning, we can use for supervised, semi-supervised, and unsupervised problem. Everywhere it can fit. All right. Moving ahead, why we need deep learning? So as we know, so manual feature extraction is not going to be possible every time. If you talk about images, there will be a lot of features. How we are going to extract the features from the image, we'll come to know. We have to mimic human brain to process the image. For mimicking human brain, we have to create neural networks, right? Artificial neural network, the neural network that we are going to create on our own. So basically handling the problems where we have to work on unstructured data like image, audio, video, like speech or text recognition, that time we will be using deep learning. Now here, basically it is going to scale the data better than traditional machine learning algorithm that we have discussed. And it is getting used in the industry everywhere. If you talk about chatbot and all, we all know about self-driving cars. It is also possible because of deep learning. Face recognition, right? You might have seen in some of the colleges, in some of the offices, there are some attendance system, right, where employee and student have to stand in front of a machine. It is going to capture the image and it is going to mark the attendance, right? All these things are nothing but possible because of deep learning. So what is the basic difference over here? In machine learning, we got the data and we have to perform the feature extraction. Then we will give it to the model. Either it is going to do classification or regression, whatever it is. Then we are going to get the output. But in deep learning, the input we are going to give and feature extraction and the classification or regression, whatever the problem that you are solving, it is going to be done by the model itself. So this is what we are getting over here. Okay, one question I got from Ram Rajan: LLM are upgraded version of the deep learning? Yes, we can say. Basically, here we are implementing NLP and deep learning all together. Okay, and LLM is nothing but based on GPTs, right? We have talked about GPT in the last session, right? So basically, it is possible because of deep learning only. Yes, you can say upgraded version or advanced version. Perfect. How deep neural network works? What exactly deep neural network is? Let's try to understand with a simple, simple drawing. So I told you that there will be different neural networks, right? If I'm going to talk about neural network, if I'm going to talk about neural network, it is going to be of different types. What are the types? So first of all, we are going to have ANN, artificial neural network. On the top of NN, we have CNN, that is convolutional neural network. Then to solve something based on time or something related to data, we are going to use RNN. Yes, I'm getting the responses in the chat. Everyone knows about it. That's really nice. All right. We will be talking about ANN, CNN, and RNN. What you can see here in this picture, we have different neurons, right? These are nothing but the neurons. Let's try to understand a single neuron first of all. Okay, I'll talk about it. Deep neural network. Deep neural network is nothing but when we are going to combine multiple layers, it is going to be deep neural network. I'm coming to it. Kausal. I'm coming to it. So let's talk about neural network. So as I told you, we are going to create neurons and we will be having some neural network like this, right? We will be having the connections like this. Let me just connect all the dots. Then you are going to get all the things at a single time. All right. I'm just connecting the dots over here. So what we can see, all the dots are connected with each other. What about this particular dot that we are having over here? This particular dot. Dot means nothing but this is our neuron. How does a neuron work? Let's try to understand. Now, single unit of a neural network that we are having over here, this single unit, we call it as perceptron. Okay, how the calculations are going to be made? Let's try to understand this particular topic, perceptron, first of all. Okay, then we'll move ahead. We'll try to understand how exactly deep learning is going to work. So I'm taking the single unit in a neural network. So let's suppose this is what you got, a single unit over here. Now to this neuron, we are going to pass some values. These values are going to be nothing but the inputs. Remember the features we have in our data set. If you talk about like simple tabular data, so A, B, C, whatever you have over here, these are nothing but inputs. These are nothing but inputs. So this is what the input that we are going to give, extracted from an image or any unstructured data. So let's call it as input 1, input 2, and input 3. What is going to happen over here in this particular perceptron? I'm talking about a single perceptron. So here we are going to have multiple things done. So first of all, here we are going to have summation of inputs and weights. Now where the weight will come? So weights are going to be given by the model itself. We are not going to give the weights. Weights are going to be given by the model. And one extra term can be added by the model. We call it as bias. Bias is just going to be used to balance the equation. Weights and biases we are not going to assign. It is going to be given by the model itself. What we will be giving to the model, the inputs. Okay, after getting the summation of inputs and weights, let's suppose this summation of inputs and weights, we are calling it as x. So this x is going to be passed through a function. We are going to call it as activation function. This fx is going to be nothing but over here. We are going to call it as activation function. What activation function is going to do, I'll tell you. Activation function. So input and weights are going to get, we will be getting the summation of inputs and weights, and that particular summation is going to be passed through activation function, and we will be getting the output or the result. So this is the thing that is happening in a single unit. This is the perceptron, and what it is getting? It is getting inputs from all the features, right? These are going to be nothing but the input features. Now, one more question over here. Sir, how calculations are going to be made, right? We have written the things, okay? We have seen the picture, but how? How the things will work? Let's try to understand. First of all, I told you we will be having the summation of input and weight. So how it is going to be calculated? So here we will be having, let's say, I1 into W1, input weight, input 1 into W1 plus input 2 into W2 plus input 3 into W3. And here we will be having this particular bias. Now what we are calling it as, let's say this is nothing but the x that we have calculated. X, x is nothing but our input feature, right? Independent data. Now this x is going to get passed through a activation function. For now, the activation function that we are taking, let's say we are taking sigmoid. All of you are familiar with sigmoid. We have discussed about sigmoid before, but I'll tell you what exactly sigmoid is going to do. There will be different activation function that we are going to do. Over here, the sigmoid is going to follow this particular equation. 1 by 1 plus exponential of inverse x. Now, what this formula written? I have told you. Can anyone tell me what this equation is going to do for us? Anyone? What you're going to get from this equation? Yes, a value between 0 to 1. Right? We have already seen, we have already used sigmoid function if you have used logistic regression. So like sigmoid function, we will be using different activation function also. When I'm going to implement it, I will be letting you know how this particular activation function is working. So this is how the whole calculation is going to be made in a single unit of a neural network that we used to call it as perceptron. So perceptron is nothing but single unit of a neural network. single unit of a neural network. Is it clear till here? Can I get some thumbs up over here in the chat? Or yes, you can write clear. Right? Perfect, perfect, perfect. Now, how we are going to combine all the things together? How we are going to combine all the things together? Let's try to understand. We will be working on a problem today. Let me write the title of our project today, the first project that we are going to see, and it is also known as Hello World of Deep Learning. We are going to work on a problem called handwritten digit recognition project. Handwritten digit recognition. Now, handwritten digit means what? We will be having thousands of images of handwritten digits. Like it could be, let's say, 4, it could be 3, it could be 7, and in different way. In different way. Someone write 4 like this, someone write 4 in different way. Let's suppose I'm going to write 4 like this. Right? We will be having, like different handwritings and all. So there could be difference. As I told you in number 3, I have written number 3 in multiple ways. But here we will be training a model that is going to recognize all the patterns that is related to number 3. All right. Now, basically, we are going to have an image. We are going to have an image, first of all, right? We are going to train the model on image. Let's take one image. I'm taking an image of number 3. All right. Can anyone tell me what is an image made up of? So here I will be dividing the image into, let me do one thing. Let me draw the lines. That would be fine. I'm getting the right answers here in the chat box. An image is made up of nothing but pixels. So here I'm just creating a grid, and each cell in the grid is going to be 1 pixel. Just a second. All right. Done. So an image is made up of nothing but pixel. Let me take the number. Yeah. An image is made up of nothing but pixel. And one pixel value ranges between 0 to 255. 0 to 255. Now, yes, exactly, Bala. Each pixel has a value. So as we know, all the pixel values is going to range between this number 0 to 255. So that means in some of the pixels we will be having 0. In some of the pixels we will be having some numbers. Let's say a number between 200, 0 to 255. So let's suppose this pixel is having some number like 210, 190, 100, 80. I'm just giving the random numbers over here. Let's say 70, 120, 180, some numbers here, some numbers here, here, and let's suppose rest of the pixels are having the value 0. Now what we can observe over here, if I'm going to count all these things, like if I'm going to count on, I'm not going to add, if I'm going to take this particular numbers, if you are going to see these numbers are nothing but representing a pattern. That pattern is going to be about the number 3. But our job is not done till yet. What we are going to do next? Now the thing is that 0 to 255, the numbers 0 to 255 are going to be large numbers. right? Okay, color codes we'll be talking about in the next project, Devasis. Right now, let's suppose the image that we are having, we are just taking out the pixel value. Okay, right? It is nothing but color codes only. We'll be talking about color codes. We'll be having extra parameter as well for color codes. All right. So moving ahead, what we are going to do, we are going to normalize this particular array. Now with the number, with the help of pixel value, what we have got, nothing but an array. Now we got the numbers, we have got nothing but a 2D array over here. Now this array need to be divided by 255. Why we are going to divide it by 255? To normalize it. Now when you are going to divide, when you are going to divide the number, any number, to the range of the highest number, so that is 255, it is going to convert or normalize all the values between 0 to 1. What we are achieving by compressing all the values or normalizing the values to 0 to 1? So here, what exactly we are trying to do? We are trying to reduce the computation cost, complexity that we are going to give to the model. So we will be giving thousands of images. Now computer is going to calculate, the model is going to calculate all the numbers. Now when you are going to give thousands of images or millions of images, these numbers are going to be quite large. When you are going to start calculation, computation cost will be high, model will take more time to train. So that's why we are going to compress it in between 0 to 1. That is nothing but normalizing it. It will be 0 to 1, right? What is going to be the next thing that we are going to do? Now let's suppose the image that we are having, this image is made up of 28 by 28 pixel. 28 by 28 pixel. What we are going to do next? Okay, we have got an array, we have normalized all the values between 0 to 1. The next thing we are going to do is going to be flattening. Okay, flattening means what? Converting this 2D array, converting this 2D array to 1D array. 2D array to 1D array. Okay, now tell me, if I'm going to convert this particular 2D array to 1D array, like this, a 1D array like this, and if we are having starting from 1, what will be the total size of this array? Let's suppose we are having the values like this. Okay, so let's say 0, 0, 0 0.9, 0 0.8, 0 0.7, 0, 1, 0, 0. Yes, we are going to convert this 2D array into a 1D array. Can you tell me, like, if I'm going to take the length, what will be the length if I'm using 28 by 28 pixel image? What will the length of this particular array? Yes, m into n. Can anyone tell me what will be the result of m into n? Exactly, your equation is right, Anamaya. I'm talking about the result. Like 1, 2, 3, and it is going to end at exactly. That is nothing but 28 into 28, and it is going to be nothing but 784. 784. We have arranged all these things in an 1D array, and what will the length of, yes, height into width exactly, is going to be 784. Now this 784, what exactly this 784 is nothing but we are going to take it as input. This is going to be nothing but input of 784, input of 784. So here, let's suppose we are arranging all these things over here like this till 784. So it is starting from input 1 to input 784. Then like we are going to see two type of architecture. We are going to have one input, then we will be having output layer, input layer and output layer. In output layer, let's say how many numbers we have. We have numbers from 0 to 9, right? So total 10 neurons we are going to have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we are going to pass all the inputs to each and every neuron. We are going to pass all the inputs to each and every neuron. I won't be able to connect all the dots, but I hope you can understand if I'm going to connect all the dots, how it will look like. So we are passing all the inputs to all the neurons. All the inputs to all the neurons, like this. Right. Now, in input layer, we are not going to have anything. But here we are going to have one activation function. Let's say we are having sigmoid. We are having sigmoid over here. What exactly is going to happen over here? Let's suppose we have passed one image of 3. We have trained the model. When we are going to pass the image, so image will be get converted into this particular 1D array, right? After normalizing and all. So this image is going to get passed, the values is going to get passed and calculated. How the things has been calculated, I have already told you over here. Okay. Calculated, and it will be passed to each and every neuron, and each and every neuron is going to give one output. And this is going to be nothing but one array only. Okay. This is going to be an array of outputs. Now let's suppose the first neuron is representing, let me change the pencil color, just a second. 0. This is representing 1, 2, 3, 4, 5, and till 9. If I'm passing the value of 3, like if I'm passing an image of 3, it will get passed through all the things, right? Pass through this layer. All the things get calculated, and here we are going to have some output. What will be the output? Let's say this first neuron is going to have the output like 0.15. That means I am 15% sure that this number is 0. Here we are going to have 0.21. I am 21% sure this number is 1. It will have something like 0. Let's say 42. I am 42% sure this number is 2. But when it comes to the 3, like over here, we will be having some number like this 0.96. I'm 96% sure this number is 3. Now again, if we'll go to 4, it will reduce 3.3. I'm 33% sure this number is 4, and so on. What is going to be our job over here? To find the index of highest value neuron. So here we will be taking the help of NumPy. So in NumPy, we are having one function called argmax. We are having one function called argmax. If you're going to pass a list over here on array, it is going to return you the index of highest value element, right? And with the help of index, we will be able to find out. So if the index is 3, then the output is going to be nothing but 3. Is it clear till here, everyone? Are you able to understand how neural network is going to work? Any doubt till here? Okay, let me summarize it. Okay, sure. So what we are discussing right now, we have started with deep learning. We understood the concept of perceptron. Perceptron is nothing but a single unit inside a neural network. This is how the things will get calculated in a single unit of a neural network, that is perceptron. We will be passing all the inputs, and all the inputs will get assigned with some weights. Weights and bias is going to be given by the model. What is bias? Bias is nothing but an extra term that is added by the model to balance the equation. Then all this all this particular summation is going to be passed through an activation function. For example, we are taking sigmoid, right? So we are talking about this particular problem, handwritten digit recognition, where we will be having 28 by 28 pixel images in the form of array. We will be so the pixel value is going to be 255. We'll be dividing it by 255 to get all the values normalized between 0 and 1. We are going to convert this 2D array into 1D array. That is going to be nothing but flattening. This flattened layer is going to be nothing but our input data, right? We will be having one image. That image will get flattened and it will be taken as input layer. And all the inputs we are going to pass to a neuron. Input 1 to input 784. Right? 28 into 28, 784. This is how neural network, the connection is going to be made. Okay, one question over here from Sian. I'm doing a project on healthcare diabetes one. Sir, my care model should give 100% accurate result. No, no. You can't assume 100% result every time. Your accuracy may be 90%, 95%, 99%, or even 70%. Okay? You have to try to improve it. Like, you're not going to say like every time you're going to get 100% accuracy. Okay? If your model is giving more than 80% or 90%, go ahead. All right, guys. So this is what the first architecture that we have seen. We'll be talking about more now. Okay, let's try to implement all these things through Python. Okay, so I have prepared this particular notebook for you, where we are going to use one library that is going to be nothing but TensorFlow. One question over here, sir, what is TensorFlow? Why we are using it? So as we are doing deep learning project, we need some deep learning framework. TensorFlow is one of the framework. Okay. Activation function, I'll come to the activation function, Lohita. I'll come to it. So TensorFlow is going to be a deep learning framework that is developed by Google. There is one more deep learning framework that is getting used in the market, that is nothing but PyTorch. PyTorch was developed by Facebook. Now it's Meta. Okay, you are asking me to share this notebook. We are not using scikit-learn for now. Scikit-learn is not deep learning framework, Anamaya. We have to use deep learning framework. Let me share this file. Just a second. I'm sharing this file here in the chat so that everyone can use. Just give me a minute. I know all of you want to use this particular things. You want to, work with me, along with me. Okay. So I have shared this particular file in the chat box. Okay. You can see I have shared this. You can download it and directly you can use it. So first of all, what you need to do, you need to install TensorFlow. If you are using local system, in your local system, TensorFlow will not be installed. But if you talk about any online platform, TensorFlow will be there. So we need to install it. I'm not going to install it because it's already installed in my system. So we will be using NumPy, TensorFlow, as I told you, TensorFlow, the deep learning framework. From TensorFlow, we are going to use one more module that is going to be Keras. Keras is going to help us to create layers in the neural network. It will help us to create neural networks, the layers in the neural network, and how many neurons you want, that will be taking from Keras. In Keras, we are having one more module called layers, and layers is going to have a function called dense. So dense will let you know, didn't receive the link. I have shared the file to everyone. You can see here in the chat. In the chat box, file not arrived. Okay. It will not open it. You have to download it. Okay. You have to download this file. Click on the three dot that you're getting. Okay. No problem. I will be sharing it with you in the Telegram group. Done. Okay. Ramanjan has already downloaded it. After downloading, it does not open. It will not open directly. You have to open through Google, sorry, Jupyter Notebook. Right? Download the file and open in Jupyter Notebook. All right, let's move ahead over here. Yeah, we will be having some plots also. We'll try to plot few of the things. For plotting, we'll be using Matplotlib and Seaborn. And here I have just imported warnings. I don't want to see the warnings over here. Okay. So which data set we are going to use? We will be using MNIST dataset that comes from Keras datasets. Okay. Now Keras is having lot of dataset. Let me show you. You can simply go on, your browser. You can search for Keras dataset. You will be getting this particular link, the official web page. Let me just open it and show you. Here you go. Right now, we are using this particular dataset, MNIST digit classification dataset. Okay. You can also work on these datasets as well. There is one more regression project as well. Okay. So try to also work on different datasets. So right now I'm using this one. You can also work on this one or this one. Right. Cipher 10 small, like 10 different images for classification. Here, this particular dataset will have 100 different images for classification. Fine. So you can directly download it over here. So what I'm going to do, I'm going to run this code. What I will be getting from keras.datasets.mnist, load data is going to be the function that will help us to download the dataset. And when I'm going to download this dataset, I'm going to assign this into two different buckets. That is going to be train and test. X train and Y train, X test and Y test. Let's run this and done. It's got loaded. Okay. This is not pre-trained data set. Okay. This is not pre-trained data set. Pre-trained model we have, not pre-trained data set. There is no pre-trained data set, something like that. Now, what is the length of our data set? So for training, we will be having 60,000 images as array. For testing purpose, we'll be having 10,000 images as arrays. Now, if you're going to see the shape, so shape is nothing but 60,000 by 28 into 28. That is showing you nothing but the size of an image. So this is going to be your size of an image. And if you're going to see the shape of this, it is going to be 28 by 28, and all the images are already taken as numbers over here in the form of array. And here you can see this is how an image array will look like. What you can see, the values is ranging between 0 to 255. 255 is the highest value and 0 is the lowest value over here. Okay. Now, moving ahead, let's try to understand what are the images we have. First 10 images we are going to see over here from the train data. So we are using Matso. Matso is getting used to also plot a matrix. So what we are having, 5, 0, 4, 1, 9, 2, 1, 3, 1, 4, and so on. And we will be having the labels in Y. X and Y, you already know what is X and what is Y. X is independent data, Y is the dependent data. So we are having the labels over here, 5, 0, 4, 1, 9 and all. What we will be doing, we will be dividing the entire array with 255 so that the images that we are going to get, the value inside the array will get normalized between 0 to 1. Done. After doing this, what will happen? All the numbers you will see in the array will get compressed between 0 to 1. Here you go. Not a single value is more than 1. Only one value you can see as 1 because the value was 255. Rest of the values are less than that, right? Ranging between 0 to 1. So the shape is like this, right? 60,000 by 28 by 28. If we talk about a dimension, the data that we are having is having 3D, like 3D data. 3D data means what? You are having 60,000 rows and each row is having 28 by 28, 28 by 28 dimension image array. So what we are going to do, we are going to flatten it. So here I am going to show you the manual method. We should know the both manual method and the direct method. Direct method also I will be showing you later on. So here we are having manual method. So what we are doing, we are flattening the array. Flattening the array means what? We are changing the shape of the array. We are going to make it from 2D to 1D array. So xtrain dot reshape, we are giving the number of row as it is the length of xtrain, that is 60,000, but the columns 28 by 28, right? Similarly, we are going to do the same with test. Here we go, done. Now the shape you are going to see is 60,000 rows, sorry, 60,000 rows with 784 features. 784 features we are having for each and every image. 784 features. Now, if you are going to see the data over here, you will find this is 1D array. You can see it is 1D. Now we are able to achieve 1D array. The next thing, let's try to build the model and train the model. So we are having a code over here from Keras that we have imported from TensorFlow. Keras.sequential. Sequential is going to be the model that we are going to use, and that will help us to create the layer inside it. So here, right now, we are just going to have one input layer and output layer. For input layer, you are not going to mention anything. You are going to mention the input shape, right? Then keras.layer.dense, we are mentioning 10. So right now we are following this architecture. We are having input layer and we are having output layer of 10 neurons. In input shape, we have given 784, right? All right. So this is how the model will be created. Now we need to compile the model. We need to add few of the things. Yes, one more thing is there, activation function. So this is how we are going to assign the activation function. I have already told you about sigmoid, what sigmoid is going to do. So you can also say activation function is nothing but decision maker of the cell. Decision maker of the cell. So whatever the calculation is getting done, the summation, it will get passed through activation function. Right now we are using sigmoid. I will be also showing you one more activation function. Okay, so all the calculation will made through activation function and we will be getting the output, or this output can be given to the next layer that we are going to see next. So we are going to compile the model. In compile, we will be having few of the things. Now optimizers. Now what are optimizers? Here we are using Adam. There are different optimizers also. Optimizers are going to be responsible for assigning the weights and bias, the values of weights and biases to the model, right, in the neural network. So weights are going to be nothing but the more the weights, the highest value that we are having for the highest value we will be having for a particular feature. Okay, it is also going to show the importance of the feature. Then we are going to have loss function. Okay, what type of problem we are having right now? We are having classification problem, and we have already discussed there are two type of classification. There is binary classification and multi-class classification. Right now we are having multi-class classification because we are having 10 classes to predict, right? Our model is going to differentiate between 10 different classes, that is 0 to 9, 10 different numbers. For multi-class classification problem in deep learning, we use sparse categorical cross entropy, the loss function. If you are going to work on binary classification, you are going to use binary cross entropy. Metric, as we are using, as we are into classification problem, so you know metric is going to be nothing but accuracy only. All right, so this is how the model will get compiled. Now let's try to train the model. Model.fit. What we have given, the X data and the Y data, and then what we have, epochs. What is epochs over here? Epochs are nothing but the number of iteration that we are giving the model to train. So model will take 5 iteration to train itself. And after each iteration, we will see some change in the model's accuracy or the loss is getting generated by the model. Let's run this code and let's observe the changes. So epoch 1. So what we are getting accuracy is 80%. So 80% accuracy we are getting only for train data right now. We are not talking about test data. So after 5 epochs, what we have got, 92% accuracy, right? 92.5. But it is nothing but it is train accuracy. Let's run this. Sorry, let's see the summary. So what we are having, nothing but uh, one output layer, only one layer we are having in this, like input layer. Input layer is not going to be considered over here in this because we have directly passed it over here as input, say. All right. So here, what we are going to do, we are going to evaluate the model giving the test data. So model will get evaluated, and what we have got, we have achieved 91% accuracy, 91.3 for the test data. So not a very big difference, 92 and 91. So we are having 1% of the, we are having 1% of the, difference between training accuracy and testing accuracy. Okay, people are asking me to share the GitHub link. Okay, that is going to be the best option. Let me share the GitHub link. Just a second. I'm having this project on GitHub. Let me share the GitHub link. Just a second. And written. Okay. I have given you the code, but I have already given you the notebook. Okay. There will be a little bit difference between the link that I have said, the notebook that you're going to have, but you will be able to run the things. Okay. Now what we are going to have, we are going to see where our model is lagging behind. Okay. So we trained the model. We achieved 91% accuracy on the test data. What about the 9%? Okay. What about the 9%? 9% are nothing but the errors. Okay, 9% are the errors. Okay, one question over here. Could you explain epochs and the loss? Sure. Epochs are nothing but the iteration, number of iteration that we are giving to the model to train. So model will get trained in 5 epochs. Each time the data that model is going to get is going to be little bit different, not with the same data. It will be having different set of data. We will be passing the data in different batches, right? And loss is saying you nothing but what loss it is making, how much particular errors are coming. Loss are the different values over here that tells us how the model is lagging. Okay, so what we are going to see, Here we are going to ask the model to predict the test data. Like we have used in, like we have done the same thing in the machine learning projects. X test flattened. So model is going to get this thing and we are going to see what we are having on the index 0. So what we have on index 0 we have an array of 10 values. That means nothing but the first output, calculation of the first output, right? What we have on the first index, 0 index of X test, we have 7. Let's try to find out what is the maximum value element over here, the index of the maximum value element over here. For that we'll be using argmax of index 0. It is saying 7. Now the image that we have passed 7, the value that we have got 7. What we are going to do, we will be taking the argmax of all the values in this particular y predicted list. All right, so we will be getting all the things assigned here in y predicted labels. What are the first 10 values? These are the first 10 values predicted by the model. 7 we have already seen. It is 7210414,969. This is what the model has predicted. Now we are going to see what the actual image is there. So these are the predictions and these are the images. 7, 2, 1, 0, 4, 1, 4, 9, 6, 9. All right. So what we can see, all the predictions are correct, right? All the predictions are correct. But where are we having the errors? Which labels are not getting predicted accurately? How will come to know? We have used confusion matrix before. The same we are going to use it here as well, but not from scikit-learn library. Here we will be using from TensorFlow.math. TensorFlow is having a math module. You can do all the mathematical operations from here also. We will be using confusion matrix. Here we are going to give the labels. Label means what? The actual value, that is y test, and predictions. Predictions are nothing but the predicted value that we have got over here, that is y predicted labels. This is what the confusion matrix we have got. Better to plot it. How we use to plot it? With the help of heat map. Here you go. Right? Now what we can see, if you see this particular predictions over here, let me just reduce the screen size. You will see 2 got predicted as 8 39 times, huge number of errors. And 4 got predicted as 9 24 times. 5 got predicted as 8 27 times, and 5 is getting predicted as 3 29 times. So these are the high number of the errors. What we'll try to do, we'll try to include one extra layer in our neural network. Okay, one question is here from Tanvi. I am using 20 epochs. Is this okay? Okay, what about diagonal value? Okay, very good. Diagonal value basically says 0 got predicted as 0 966 times. 1 got predicted as 1. It is nothing but value getting predicted as the same. That is the true levels, the true predictions. So this diagonal shows the true predictions. The value got predicted as the value itself, right? Okay, one question is about epochs. I'll tell you about epochs. Here I have mentioned 5 epochs, right? I have mentioned where it is our training part, 5 epochs. Now the question is, can we use 100 epochs? Can we use 200 epochs? The answer is yes, you can increase the number of epochs. Now one more question. For 5 epochs, we have seen the accuracy is getting increased. Are we going to achieve more accuracy when we are going to increase the number of epochs? The answer is yes, you can, but sometimes you cannot. Then what is going to be the solution? I'll tell you the solution over here in the end of this file. There are going to be some regularization technique. Now, the problem is, let's suppose I am using I'm using 100 epochs, but at some point of time, let's suppose I have started the training, I have given the number of epochs as 100. What can happen after 60th epoch? Model accuracy can start degrading, loss can increase. That time we use one regularization technique, that is going to be early stopping. Early stopping means what? We will tell the model, monitor the loss. Monitor the loss. If loss is going to increase in certain number of iteration, stop the epoch there itself. I'll tell you how it's going to be implemented. In this file, I have added the code. All the things will come. Okay, let's move ahead. What I told you here, we have got a 91% accuracy, right? For the test data. Here, what we are going to do, we are going to increase one more layer over here. Now, what we are going to have, 100 neuron layer that will be given 784 inputs. After that, we will be having one more layer. What this architecture is, how it will look like. Let's try to figure it out, how this architecture will look like. So right now, what we have over here, we have input layer, then we have output layer. What we are trying to implement, we are trying to implement one more type of architecture, not different type. We are adding something. We will be having input layer of 784 inputs, right? Then we are going to have hidden layer. We are going to have hidden layer of 100 neuron. I am taking 100, you can take 200, you can take 300, you can take 1000. Okay, then we are going to have output layer. Output layer of again 10. How the things will goes on? Yes, we will be having the inputs like this. How many inputs? From I1 to I784, and we will be having 100 neurons in hidden layer. Now, any number of layer you can add over here in hidden layer. You can have 2 hidden layer, you can have 3 hidden layer, you can have 5 hidden layer. It's on you. So how many neurons we are having? 100 neurons in the hidden layer. Then we are going to have 10 neurons in the output layer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, all the dots are going to be connected to each other. Dot means what? Nothing but we are passing all the inputs to each neuron. So each neuron is going to be connected with all the inputs, and all the neurons in the next layer is going to be connected with all the neurons in the previous layer. How many layers you are going to add? It's totally depends on you. You have to see. Okay. So I won't be adding all the dots. I hope you can understand all the neurons are interconnected. That means all the neurons, like all the inputs is going to get passed to this hidden layer, all the neurons of the hidden layer, all the hidden neurons of this hidden layer is going to have some calculation, and all the calculation will get passed to the next layer, that is going to be the output layer. Okay. Epochs means the number of iteration the model is taking to train. So simply model is going to, if I'm taking epochs as 5, if I'm going to take epochs equal to 5, that means model will train this many times, 5 times. But different set of the data from the given data set. Not the same data in each epoch set the model is going to take. We have stop at I -1. Okay. Yes, I minus 1. First of all, we have to find out, Devasis, what is going to be the good number of epochs. Good, not good. Yes, it is good. I hope you understood this architecture. Now, one more thing we have added over here. The activation function that I am using over here is ReLU. In hidden layer, we are using ReLU. Here, the activation function we are using in the output layer is going to be sigmoid. Now, what is ReLU? ReLU is very simple, very, very simple. ReLU works in this max of 0 or x. Now, what exactly ReLU is going to do? ReLU is going to convert all the negatives to 0. Now, if what we are having, if two things will come, if your x is positive, it will return x. If your x is negative, it will return 0. Right? Yes, you can use 10 epochs. I will be using 10 epochs in front of you. Just wait and watch. So this is how ReLU is going to work. ReLU is going to convert all the negatives to 0 from the layers, that whatever the neurons you are having. All the neurons that is having negative values will set to 0, and all the values that is having positive values, only those values will get passed. So it is also going to increase the efficiency of the model. So this is the same architecture we are using over here. So we are having two layers. Input SEP is over here. That means nothing but input layer. We can also implement it in different way. I'll tell you how to do. 100 neurons in the hidden layer. You can have more hidden layer. Activation function that we are using ReLU. Then activation function we are using in the output layer with the 10 neuron is sigmoid. Rest of the things are same. We are going to train the model again for the 5 epochs. Let's train the model. What you can see, in the last training, we have got 92% accuracy in the 5th epoch. Here we have achieved 96% of the accuracy here itself in the 2nd epoch only. Sir, can you explain what is ReLU? Okay. Let me take this again. So ReLU is going to, let's suppose you are passing the x over here in ReLU function. ReLU is the activation function that is simply going to work like this. Max of 0 and x. I have explained the things over here. How sigmoid is going to work? Sigmoid is going to work like this: 1 by 1 plus exponential of inverse x. It is going to return a value between 0 to 1. How ReLU is going to work, I have explained over here. So if x, that the summation that you're getting, x is nothing but the summation, right? X is nothing but the summation of inputs and weights that you're having is x. If x is positive, it will return x itself. If x is negative, it will return 0. That means it is going to set all the negatives to 0. Yes, exactly, Annamaya. Correct. Let's come back to our file. What we have achieved 98.5% of the accuracy in training data. What is the summary of the model? If you see the summary, what we are having, one layer of 100 neuron and one layer of 10 neuron. That is the output layer. Yes, 90% accuracy we have got on trained data. What about test data? Let's evaluate the model on the test data. On test data, we are getting 97.5% of the accuracy. That is good, not bad. 1% of the difference we can see. Let's try to repeat the step where we are going to ask the model to predict the test data. We'll be storing all the labels that has been written by the model, and we are going to see the confusion matrix. Here you go. Now what you can see, 3 was getting predicted as 9, like 30 plus times, but now it is only 2. 5 was getting predicted as 8, 20 plus time, now it is only 2. You can see so many values, like the errors has been reduced. So many errors has been reduced. This is what we have achieved just by adding one more layer, right? Now, I told you over here, if you remember, this flattening part, we are doing it manually, but it can be done in on the go as well. If you don't want to do it manually, what you can do? Here I have added one more line of code. This one. So what we are adding over here, we are having a flatten layer. In flatten layer only, we are going to mention the input step. So input step is going to be 28 by 28. Here we are not going to pass the flattened data to the model. We will be passing directly the train data. Right here, the manual thing has been reduced. You are not going to flatten it manually. Directly, you can use the flatten layer. This flatten layer is going to be nothing but your input layer. Then what we are having, two hidden layers. One hidden layer of 512 neurons, one hidden layer of 256 neurons. Here I have taken all these things randomly. You can also set it 100, 100, 200, 300 like that. But on the output layer, it will be 10, right? Because we are having 10 classes. For each class, we are having one neuron. So this is how we are going to train the model again. And here I have increased the number of epochs. Let's see the things will change or not. Let's run this. And let's wait and watch the accuracy. For the first epoch, we have got, I guess, 90 plus percent. Yes, 90 plus. This is 90 plus for the first epoch. On the second epoch only, we have got 97, right? What we have done, we have added two layers over here in the hidden layer. Till the training, let me explain you this thing, like how the things we have done now. So we are having the input layer, and input layer is nothing but the flattened layer of 784 inputs. Then we have hidden layer. Let me write HL, hidden layer 1 of 512 neurons, and hidden layer 2 of 256 neurons. Then we are having one output layer. The output layer is of 10 neurons. So this is how the things will be there. So we are having till 784 over here, 0 to 784. So that is nothing but 1 to 784. Then we are having 512 neurons, 1 to 512. And activation function, we are using ReLU over here. Here we are having nothing but total 1 to 256 neurons. ReLU activation function has been used here itself. And we are having 10 neurons in the output layer. We have used sigmoid over here. Sigmoid. And all the things are going to be interconnected. All the neurons in the next layer is going to be connected with all the neurons in the previous layer, and all the neuron in the next previous layer will be connected to all the neurons in the next layer. This is how the neural network is going to be. Okay, so few chats I have got, sir. I reached 98.97% accuracy in my personal project. Very good, Prince. What I have got, okay, my 10th epoch is going to over. And now why it is taking so much time? Because number of neurons we have added quite high, right? One more hidden layer is there, and if you are going to increase the number of neurons, so computation is going to be high, right? Done. We are done. So I have achieved 99% of the accuracy on the train data. It doesn't even matter how much you're getting on the train data, you have to evaluate on the test data as well. On test data, again, I'm getting 97% only. Okay, I'm getting 97%. Is it clear till here to all? Is it clear to all? Can I get thumbs up from everyone? Yes or clear? Perfect. Number of epochs 10 is good or not? It is good. I'm not saying it is bad. Let me tell you, we are having one regularization technique. I'll tell you over here. This one. I have added this code over here. I'm not going to run this. So what you can see, what we are having something called early stopping. Early stopping. Early stopping will come from callbacks. You have to import callbacks from Keras. So here you have to create one object for that. Okay. So these are nothing but this is different optimizer. Like we have used Adam here. I have implemented other things so that you can try different algorithm as well. Okay. All right. Okay. Just try to focus on these things. Okay. Just try to focus on these things. We are using early callbacks, early stopping. We are creating an object that is going to monitor validation loss, or you can simply mention loss. And here we are mentioning patience too. Patience could be 2 or 3. What does patience means? So what can happen? Let's suppose you are training the model for 50 epoch. On the 40th epoch, model performance start degrading, but it could increase in the 42nd epoch. So your early stomping is not going to work on the same epoch where the model started degrading. It will have patience till 2 more epochs. It will have patience till 2 more epoch. It will wait. It will have patience. Even the model performance is degrading, then it will stop. So we have to add patience. Patience you can add 2, you can add 3. Okay, you can check this thing. Okay, on your own. So this object, this thing that we are using, we can apply this thing in model.fit. In model.fit, what we are having? Train image, test labels, right? That is the both, that is X train and Y train labels. I have given the name. Epochs, you can mention any number. You can also mention the batch size, number of data points will be taken. Validation split. If you're going to pass the entire data to the model, then you are going to have validation split. So 20% data will get splitted over there itself. And here you go, callbacks. Callbacks will help you to uh, understand where you have to exactly stop the training of the model in the epochs. I hope everything is clear till now, guys. Is it clear to all? Perfect, perfect. So this was nothing but a project that we have done on deep learning using deep neural network. So someone asked me what is deep neural network? Nothing but when you're going to have multiple layers like this, when you're training, we call it deep neural network. Okay, deep neural network. You are having multiple layers over here. From here it got its name, deep learning. Sir, why LMS is not opening? It will open. So Prince is saying, sir, I have used CNN and Streamlit in my project. Very good, Prince. Can go ahead now. You can create the PPT, you can submit the project. All right. So the next thing that we are going to discuss is going to be cat and dog image classification project. Okay, cat and dog image classification project. Can we proceed now? Can I get some quick yes again? Perfect, perfect. All right, so here we are going to again learn a lot of things about CNN over here, and we will be using the same framework, that is going to be TensorFlow, the deep learning framework. So we are going to use one more thing from Keras. In Keras, we are having something called preprocessing.image. From there, we are going to use image data generator. Now, why we are going to use image data generator? Here we are going to use real-time images. Let me show you. Let me first of all, import this thing. I will be sharing this thing with you. Send the file like before. I will send the file, but how you're going to download the data? Let me show you the data set. Okay, just a second. Let me show you the data set where we have the data set. I have the data in my drive. I'm going to just show you all the things from my drive only. So here I'm having one folder. I will be giving the link to this folder. Guys, I just want you to watch all these things. Okay. Prince is saying, sir, Keras versus that H5. It depends, Prince. It depends, problem to problem. But most of the time, you can go with H5. You can also go with Keras. Okay, guys, just look at the screen right now. What we are having cat and dog images over here. Yes, it is too old, but for some problem statement, you can use H5, but better to go with Keras. I told you. Okay, so here what we are having, train and test folder, two different directories we are having. Okay, I'm talking about directory. Directory means nothing but folders. Let's talk about train folder. In train folder, again, we are having two folders, cat and dog. So what we are having in the dog folders, we are having real-time images of dogs. Here you go. So dogs images of different quality, different shapes, you can see different size. So real-time images we have. Let's close it out. Let's look into the cats folder. So you can see different cats images we have of different quality, right? Different size. So this is going to be our training data. And similarly, we are having the same type of data in test folder also. In test folder, I am having cat and dog images, right? So we will be training the model on this data. I will be explaining all the things step by step. Just guys, wait for a few minutes. I will be sharing the codes with you. Okay. Just try to focus on the screen right now. If I'm going to share the file with you, you will miss few of the concept. We are going to learn a lot of things over here. Okay. Now one of the regularization technique we are going to use over here, that is going to be image data generator. Whenever you're going to use real-time images, you are going to use this particular module, image data generator. What it is going to have, it is going to have multiple things. Let's try to understand. We are going to create an object of train data generator in which we are going to have one parameter called rescale. So rescale 1 dot. 1 dot means what? 1.0. 1 dot by 255. Now what is 255? 255 is nothing but the highest value of the pixel, right? So 1 to 255. So all the image array will get multiplied with this particular thing and it will get normalized. Shear range, zoom range, horizontal flip. So two more things we are adding. So shear range is just going to shear transformation. It is going to tilt the image along its axis. That means it is going to rotate the image little bit based on the radian that you are giving. So here we are giving 0.2, and based on the images, it can vary up to 0.2 radian. My voice is not clear. Is my voice clear? Can anyone confirm? Hers is saying my voice is not clear. Clear, right? Hers, check on your own end. Might be having some network issue. Then zoom range. Here we are mentioning zoom range 0.2. That means it can zoom in or zoom out up to 20%. Then we are having horizontal flip equal to true. Similarly, you can also have vertical flip as well. I'm not adding this, you can have vertical flip as well. Why we are doing all these things? This thing you understood, right? Why we are using it? To rescale all the things, to normalize all the values in the image array. Shear range, zoom range, and horizontal flip. So basically, it is tilting the image on its axis. It is zooming in or zooming out up to 20%. And horizontal flip, it is going to flip the image upside down. Sorry, right to left. Right to left. If you are going to use vertical flip, it will flip upside down. Why we are doing all these things? To give each and every angle of the images to the model, right? So if I'm going to train the model on cat images, I'm not going to train on the same image all the time. Or I want the model to get trained on each and every angle of a particular image. Just try to think on traffic signal, CCTV cameras are there. Behind that, helmet detection system is working. Now that model need to be trained on the different angles of the people wearing helmet or not wearing helmet. So that is what we have to do. We have to train the model on the images array, the image of a particular object from each and every angle. That's what we are trying to do. Okay. Then what we are going to do, we are going to use the same thing over here, this object to import the image. Now here I'm importing the image with the help of train datagen, this object that I have created. This object is going to have one function, the one method called flow from directory. Directory means what? Folder. Now here we are not having files over here as CSV file or any other type of file. We are having real-time images that has been separated in two different folders. That folders are going to be treated as a class. So what we are passing over here, path. So these images I have stored in my D drive. In D drive, I'm having the same folder cat and dog, and there is a folder called train. So I am giving the path of this folder. So flow from directory. Directory is nothing but another name of folder. Target size 64 by 64. What I am trying to do over here. Now you have seen the images that we have are of different, different size, different quality. Whatever the image size is, I'm going to take all the images in this particular ratio. Yes, it's image aspect ratio. All the images will be taken as 64 by 64 pixel image. It will get compressed. Batch size. I'm creating batch of 32 images at a time. You can create 64, you can create 100 also. Class mode binary. We are having only two folders, right? That's why class mode binary. Let's run this code, and what we have got, it's saying found 557 images belonging to two classes. So in the both folder in cats and dog, adding both the number of images, we are having total 557 images. The same thing we are going to do with the test data. For testing purpose, we are having 140 images that is belonging to different classes. And here we are having 557 images belonging to two different classes. Yes, very small data set. Why I'm using a small data set right now? Because it is going to take a lot of time to train, right? I have to also explain you the concept as well, right? Now here comes our CNN model. Okay, right now we haven't implemented CNN. I'll tell you. First of all, we are creating a blank model. Blank model is what? This just a model without anything. We are not having any layer added over here. If you see over here in this particular project, In keras.sequential, we are adding multiple layers, right? Here we are creating a model. The model name I'm giving CNN. You can give any name. So this model will be blank. So from keras.model.sequential, we will be having this model. After that, we will be adding some layers. We are having one layer called conv2d. Conv2d layer will get followed by pooling layer, that is going to be max pool 2d. I will be explaining each and everything. Conv2d and one max pool layer is going to create, you can say, one layer together, one component together. We can have multiple convolutional layer like this. Then finally we are going to flatten it. Now flattening means what? You already know what does flattening means, converting 2D array to a 1D array. Then we will be having a fully connected layer. Like we will be mentioning, okay, this many units of neurons I am going to use to train the model, and activation function you're going to use as usual, ReLU. And here we are having sigmoid activation function, right? In the output layer. Output layer we are having only 1 minute. Okay, let's try to understand what will happen over here in this conv2d layer, what exactly convolutional layer is, what this pooling layer is, max pool 2d. Just remember all these things: filter 32, kernel size 3, and activation function. Now you will see one more thing over here. In input shape, I am giving 64 by 64 and one more thing, that is 3. What is this 3? You might have seen the images that we had. That images were colorful HD images. That means it is having some colors. So this 3 represents the color channels, and you know all the colors are made up of these 3 colors only: RGB, red, green and blue. So this represents nothing but the color channel. We'll be talking about all these things: filter 32, kernel size 3, what will happen in CNN. Let's come to this scribbling, and let me directly go over here. Yeah. So we are going to understand CNN, or convolutional neural network. Convolutional neural network. So what we are going to have? We are going to have one image, right? Let's suppose we are having an image array. And in this image array, we will be having, pixel values, right? Then few things I want to note it down from there that we have used, then only we will try to understand what exactly it is. We are having filter 32, that is the filter size, kernel 3 by 3. Kernel 3. 3 means what? 3 by 3. Let's try to understand. So here, first of all, the first step is going to be filtering. Filtering means what? Over here, let me write it down. The filter we have taken is 32, and the kernel we have taken 3. 3 means nothing but 3 cross 3. So what will happen over here? Here we are going to multiply this particular array like this with some value. Some values will be there, right? Some values will be there, and here also we are having some values, right? Then what we are going to get from here, we will be getting over here one more array, that we are going to call it as feature map. We are going to call it as feature map. It's same like aptitude and verbal round for interview. Okay. So what is happening over here? Let's suppose I'm having kernel size 3 by 3. So here I'm going to have, let's say, 3 by 3 over here. And this 3 by 3, uh, this 3 by 3 array is going to get multiplied with this 3 by 3 array, right? This 3 by 3 array, and we will get a value over here. Then again, it will move on. It will move on. Again, we will be multiplying it by 3 by 3 like this, and we will be getting one value over here. And this process will goes on and on and on. And so that we will be getting the important pixel values over here. Okay, important pixel values. It will be full of important pixel values. So everything is getting calculated. For one calculation, we will be having one particular value. Okay, this is what you have to keep in mind. One particular value that is going to be nothing but feature map. So what we have extracted, calculation of all the pixels and keeping it together. So we are extracting the important feature from the image. So this is what is going to happen in the first layer. The next layer that we are going to have is going to be pooling layer. So this is what we have talked about in conv 2D layer. We are going to have max pool layer, or we are going to call it as pooling layer. In pooling layer, if you are going to see, we have two things. We have two things in pooling layer. Pooling layer, we have pool size 2, stride 2. Pool size 2, stride 2. Now we are going to work on this particular feature map. This particular feature map. Let's suppose we have taken this feature map over here. Let me go with the pooling over here in the new sheet. What we have taken, two things we have taken, that is pool size is 2, stride. What is stride? I'll tell you. Stride is 2. So we are having the feature map over here that we have got above. The feature map is like this. Okay. We are having feature map. Now what is going to happen? We are going to create one more feature map with the help of this particular pooling layer. Pool size 2, stride 2. Pool size 2, stride 2. Here we are going to create one more feature map. Let's try to understand what will happen. Now, I'm just going to fill some values over here. Let's suppose we are having some values like 8, 15, 21, 11. Pool size 2. That means we will be taking 2 by 2 pixel image, 2 by 2 pixels from here in this array. And here we are going to find out which is the highest value element. So which is the highest value element? 21. 21 we are going to mention over here. Pool size 2, that means 2 by 2. Now stride 2. This is what we understood. Stride. Stride means what? Move to the next 2. Now let me write some values over here. Let's suppose we are having 16, 11, 19, 50. Now again, it is going to take 2 by 2 pixels over here, and it is going to find out which is the highest value element. So it is 50. We will have 50 over here. Similarly, from this particular feature map, the feature map over here that we have got, we are going to get one more feature map. That is going to be nothing but the convolved features that we have got. Right? So this is how the calculation will be made. And whatever the size that we are having over here, let's suppose we have got finally 64 by 64 pixels over here, or less or more. This particular things will get flattened. The next step is going to get Flatten. Now in flatten, you already know some flatten is going to be converting the image array or the featured map that we have got into 1D pixel, and you know this is going to be input 1, input 2 until input n that you have got. And here in the project that we have seen, we are having how many layers? Let's say we are having 128 neurons that we are going to have in the hidden layer, and we are going to have output layer. In output layer, we are going to have only one neuron. So 128 neurons over here and only one neuron in the output layer. So this is how the things will get interconnected. Okay, now all the things are going to get connected to the output layer. What we have done in the all the previous layers, we have used ReLU. Here we are using ReLU, and in the output layer we are using sigmoid activation function. It will give the output. So this is how convolutional neural network is going to work. Now one more question may arise in your mind. Why? Right? Why we are doing all these things? We already had what ANN that we have seen over here. Why there is a need of CNN? Let's try to understand. So right now, when you are going to work on the last images, or you are going to work on the real time images, only ANN is not going to work, because I'm taking one example of a picture over here. Let's suppose you're going to work on animal image classification project. I'm trying to draw an image over here. Not teddy. Everyone is saying teddy. Okay, it looks like teddy bear. Okay, let's suppose this animal is koala. Okay, this animal is koala. Now we are having, let's say I am going to take names from here in the from the chat. So what we are going to have, we are going to have multiple, members, like in the pixel, like in the like instead of pixel, what I'm going to take. Let me write it down just a second. What I'm going to have, we are going to have, let's say I'm going to take Prince. We have Prince, we have Chris, we have Pradeep. One more name, let me take from the chat section. We have Hari. Okay, I have just taken 4. Now let's suppose all these are reporting, all these members are reporting to one manager. Okay, these are the team members. They are reporting to a manager. Manager, let me take one name from the chat again. Okay, sir, me. Okay, so the manager is going to be, let's say, Devasis. Manager is going to be Devasis. Now we are having multiple images. We are having multiple images over here. Not only koala image, we are having different images. Now the thing is that, let's say Prince is saying this animal is koala. Okay. Chris is saying this animal is bear. Pradeep is saying this animal is panda. And Hari is saying, this animal, I think this is polar bear. Okay. Polar bear. Now what happened? Devasis will get confused. What you people are saying? What happened to you? Right? Now what will happen over here? What we are going to do here in the concept of CNN, we try to work on the important features over here. What are the important features over here? if I'm going to talk about the ears are the important features. What will happen? Let's say we will ask Prince to work on ears. We have eyes or nose. Or let's say we ask Chris to work on eyes. We have nose, right? Nose or mouth. Let's say we ask Pradeep to work on, let's say, nose. Then we have hands and legs. Let's say the different body parts. So on hands and legs, Hari is going to work, right? So what will happen? Each member will get expert in their field. Prince is going to become expert in identifying ears of all the animals. Chris is going to be expert in identifying the eyes. Pradeep is going to be expert in nose, and Hari is going to be expert in hands and legs. Now the things will change. Let me just remove the things that all the people has predicted wrong. This time everyone will say, okay, this, if I'm going to get the image of koala, everyone will say these are the eyes of koala, these are the legs of koala, these are the nose of koala, these are the hands of and or legs of koala, right? Now Devasis will come to know, his confusion will get erased, right? Now he will not get confused. He is going to give a confident answer. Yes, the animal that I have got the image of is koala. So basically, each member are nothing but each convolutional layer that we are adding, right? I hope you understood the process and the working principle behind CNN, why we are using CNN. Is it clear to all? Can I get some yes or thumbs up or clear in the chat? Okay, yes, I am trying to explain in such way even a high school student can understand what is CNN, right? Let's come to the code now. Okay, guys, code is going to take some time. Why I'm saying you take some time? The training is going to be very, of high competition. So we have run the code till here. All the things you have understood. So we are adding the first layer over here like this. So don't worry about the warnings. These are nothing but the warnings. These are not errors. And in this file, I have explained all the things over here. You can see. Here I'm adding a pooling layer. Okay. What actually the architecture we are having? Let me tell you very clearly the architecture that we are having. First of all, we are having one conv 2D plus pooling layer or max pool TD. Again, we are going to have one more conv 2D plus pooling layer Then we are going to have a flatten layer that will help us to flatten the things like converting all the array to 1D array. Then we will be having one hidden layer and one output layer, right? So this part we basically call it as full connection or fully connected layer, whatever you want to call. There are different names. How do I learn to do those coding? Pooling layer I already explained, Namrata. If I'm going to explain it again, you can go through the recording. Let me explain you in short. So we are having some important pixel values over here. In pooling, we are having two things. We are having pool size. We are having stride. Pool size means what? 2 means what? 2 by 2. We are taking 2 by 2. And we have to find out which is the highest value pixel over here. What is the highest value over here in this array, in this 2 by 2 window that we have created? It is 21. So we have taken 21 in the new feature. Stride 2. That means move to the next 2 over here. What is the highest value? 50. We have taken 50 over here, right? So this is what we are trying to do. This is what the feature map we are going to get. And this is what the architecture we are following. Chat window got closed. Just a second. So what actually we are having over here, we are having a conf 2D layer that is working with a polling layer. Then we are having one more conf 2D that is working with polling. Just a second. Then we are going to flatten it. It will become flattened like this. 1D array. Then here we will be having neurons that will get connected over here, and we will be having one output layer, one neuron. So this is how the things will work over here. Yes, exactly. What we are trying to do, we are trying to, reduce the size, weight, width, and height of the images, basically. Let's come to the code now. Okay. Last few minutes we have. All right, so we have added one conf 2D layer followed by one polling layer. The same thing we are going to do. We are adding one more conf 2D and polling layer. You can add n number of conf 2D and polling layer, 3, 4, as per your requirement. Here we are having a flattened layer. Done. Now we are having a fully connected layer. That is a hidden layer over here. We are adding with activation function ReLU of 128. You can increase the number of neuron over here. Okay. Then we are going to have one output layer, right? Unit 1 with the sigmoid. Right now, we have just created the model. We haven't trained the model. If you are going to see the summary, it will be like this. One conv 2D, one maxpol 2D, conv 2D underscore 1. That means another one you are using. You are using one flattened layer, then dense 1. That is the output layer. This is going to be the model summary. Here comes the training part. So here we are going to first of all compile the model with Adam. We are using Adam. You can use different optimization optimizer also, but Adam is going to be one of the effective optimizer that you can play blindly. Loss function here we have changed. As we are having binary classification problem, we are using binary cross entropy. Then we are using matrix accuracy. Done. Excuse me. Now we are going to train the model. CNN.fit x equal to training set. And here we are passing the training set. We are not having a x and y. Okay, we are not having x and y like the labels. Remember, we are using images. We are not having any extra label column over here. So the whole data we are giving, the whole training data, both images, cat and dog images here for x, and for validation, for each time, for in each epoch, the model is going to validate itself. Let's train it. I am training it for 25 epochs. Let me reduce it. Let me train it for 10 epochs because it's going to take a lot of time. Let's run this. So for the first epoch, it is going to take a lot of time for the first epoch only. And after epoch by epoch, after each epoch, we are going to see some increase in the accuracy. Accuracy may also decrease somewhere. Okay, one epoch is completed. Sir, how do I learn to do this coding for training models on my own? By doing it, Utsav. By doing it. First of all, you have to learn Python if you don't know. If you learn Python, just you have to remember the steps. We imported data, we did some processing, then you did some EDA. After that, you will going to split the data, you're going to train the model, you're going to test the model. Just learn the process, and after each process, you will come to know what the code I have to write. You have to do a lot of projects for that. Yes, exactly. Tawfiq sir has mentioned over here. Start with Python, then learn ML, then DL. You will start coding on your own. So you can see two things over here. We are getting accuracy, loss, and we are also getting val accuracy. That means validation accuracy, the validation data that we have given, and the loss for the same. Okay, 10 epochs has been completed. So on the training data accuracy that we have got, it's 72, and on the test data we have got 65. All right, no problem. Let's move ahead. What I'm going to do, I'm going to import one image. Okay, I'm taking one image. Let me go back to my, I have to change the path. Okay, I have to change the path. What I'm going to do, I'll go to the train folder. Just a second. Let me go to the train folder, the folder where we have in D drive. I'm having the files, D drive, cat and dog. From the test cats, let's take the cat image. I'm taking this image. I will right click on this image. I'm going to copy the path. I will paste the path over here. All right. Let's run this. Okay, it's saying some syntax error. No problem. Okay, I know what I have to do. I think I have to mention R over here. Done. Okay, so whenever you are going to copy the path directly, basically it represents like this, but by default you will be getting this backslash. How our 10 test data is like this. I have mentioned the target size. Okay, for loading the image, I'm using keras.utils.load image. I'm mentioning this size only, 64 by 64, because I have trained the model in this size only. That's why I'm taking all the image like this. You can increase and decrease the size. Then you are going to convert this image to an array. The function is image to array. That is again coming from utils. We are going to expand the dimension on the axis 0. Axis 0 means what? And if you're using numpy, axis 0 means column. We are going to expand it. I'll send you one link. No problem. I'm sending you GitHub link, Dinesh. And here we will be asking the model to predict. Let's see what is the prediction. The prediction is 1. Okay, I have tested this model multiple times. So if the result is 1, it is cat, else it is going to be dog. Let's run this thing, and what we have got, the prediction cat. We have passed the image of cat. We have got the image of cat. But you can see the validation accuracy is 65. That means model will give you like 35% of the time errors or 34% of the time errors. So you could get different result from, like I have got the correct result, but you may get different result as well. I hope this whole process is clear to all. Let me share this GitHub link. Okay, let me also share you the things over here. Just a second. I'm having this project on GitHub as well. Just a second. Yes. And you can also get this images from, Kaggle as well. I will be sharing all the links. Let me share the link of my drive as well over here. I'm sharing you the drive link of this particular image folder. Let me just click on share, and I'm giving you a viewer right over here. And here you go. You got this link here in the chat. All right. Let me know if anyone having any confusion. Is everything clear till now? Are you able to understand this concept of deep learning, ANN and CNN? Are you going to make project now? I have already done my project on digit recognition. Okay, you have used Grady also. Very good, Kuldeep. No, try to submit some other one. Okay, try to work on good project. Okay, handwritten digit is very basic project. Okay, thank you for your good word, Kangan Raj. Okay, Kugan Raj. Sorry, mine is chatbot. Perfect. Yes, sir. You can integrate LangChain. You can do this type of project. Sir, can I take help of ChatGPT? Yes, you can take help, but don't copy the things. Take help. Taking help is different thing. Copying the things are different. If you're going to copy the things, you will become Xerox machine. Don't copy and paste. Take help about the idea, the process. If you're getting error, then you can take the help. A smart plant care assistant. Yes, you can take. Guys, you can create your project based on anything that is related to AI or machine learning. If you're implementing any sort of AI over there, yes, you can submit it today. Landmark detection, yes, perfect. Okay, let me know. Yes, you can do object detection. Any doubt till here? Is everything clear? Okay, guys, ma'am has already shared the attendance form link. Yes, fill out the attendance form for the today. It's important for you, right? Fill out the attendance form. All right, so that's all from my side for today. We are going to have our last session on Thursday, that is 10th of July. So see you on Thursday. You would like to add anything, ma'am?
No, that is pretty much it, Piyush, sir. I have shared the attendance link in the chat so they can mark the attendance. Already, I have sent the same in the group as well, students. Please start working on your projects and see you all on Thursday. That would be your last technical session. And Friday, we have our last AMA session as well. Do not miss the sessions. And if you missed marking attendance for any of the sessions, please do mark it using the links that are there in the Telegram group. But before filling your attendance, do watch the recordings to understand like what all have been covered in the sessions so far. Okay. Thank you so much. Thank you, Tawfiq sir. Thank you, Piyush sir, for a wonderful session today. Thank you.
Yeah. Thank you. Thank you, everyone. Bye bye.